26 timeline. It's 23rd to the 9:31 p.m. Oh, basically ice. I got ice power with a pound of ice in me. I'm talking about American Ice Team, which are police, but the civil enforcement officers, kind of for the war aspect of things. The description of I tools of them. Or the new police force. The decentralized, because I never consider this is the police, but so. Yes, okay, so basically I got my fucking notes here, I can read a fucking dot into my fucking line because I can't see what I'm reading. And I have to prove this. I will not fuck this up, but just into my fucking life in this fucking place. This is the current, I can try and prove it wrong. So, I'm not gonna prove it now, I'm just gonna lay down the problem statement in this video, but there's no direct proof doing. Just gonna lay off the problems, enough formal grounding, so anyone can try and prove it themselves, in whatever frame they see fit. Okay, what is this? So today's video is on. Let me set my clock. My clock before I start. I'll set a 30-minute timer. Oh, this 45 minutes. 45 minutes and 30 minutes. Yeah, start. Okay. So basically, this is a dendrite proof for punk. So this is the kind of neuron sign of the neuron electrolyte sign of dilemma, because electrolytes are electricity flowing through a thick medium such as blood, but blood is same thing as water if you think about it, because blood is liquid. Liquid. Blood runs and water runs. So this is an electrolyte proof based on dendrites model. I keep calling dendrites because they have an aux input of aux star, two kind of star, an aux star, a half star, what are called two half stars. So the formal thing I'm trying to prove, drum roll please guys, is how do you use what I'm trying to prove is formally is I'm gonna say informally, but let's get to the formal setting. Basically we have an aux star, which is called an auxiliary star, to actually of a system consciously knowing ahead of time before you do it. It's like doing Chinese what I call Chinese computation. Like if I don't give you the example, you don't get it. So if I try to find out 3x plus y equals 9. 3x plus 3y equals 9, which is usually the distributive property, of 3. Divide both sides by 3, we give you 3. This is on both sides we share a trait of 3. 9 divided by 3 is 3, and x shares 3 and y shares 3. Because they distribute the way the Chinese with that. But if you're solving the American way, you're using the distributive property. So you're doing 3x plus 3y, because you just know that 3 is the shared 3. It doesn't matter because it's a simulation. This is an equation of balances the distributive equation. This is an equation that balances the system, but the balances as well. It's like literally systems of linear equation. They work on the concept of balancing because they balance. So the problem here is to define an aux star, which is the anticipation star. Do I know to do this thing to act when the noise starts? Should I start because I'm in crisis? Basically, the noise star is Miko OS starting up in crisis to resolve some kind of problem. Because if I use an aux star, do you know it's ahead of problem? It's gonna be ahead of time because my computer is start to update. To update. If it's like kind of an application, and that's an application. The aux star stands for auxiliary. It's like a geometric auxiliary computation. finding a Z and F pattern, or Z or C, C based on some kind of configuration of a system ahead of time before solving the problem of angles. Hey Deadpool, I love you too, Andy. I love you. The Deadpool book. This is one I have in the fucking hospital. I need this fucking Deadpool book. But literally, so I'm doing the medical journal on CIA, but you know, yeah. So the push. Yeah. So this is a heptagonal proof of the system. So So the heptagonian thing of the, so basically it's a heptagon question. So basically I'm gonna introduce the problem of calculus, but you know my way. So we got the kind of origami calculus model, which I'm proposing as this is a policy we're gonna use because it's just pure calculus, but it's perfectly sound, seen and sound. So this is the why it matters because you know no starts which you gotta act. It's like starting to run, but it's not. It's like starting to run, trying to basically starting to do 3, 2, 1, ready, steady, go. But you don't hear the gunshot. You know, you don't hear the gun. You don't hear the gunshot. So 3, ready, steady, shoot. And that's a noise stop because the gun goes off, but you know, some people hear it because they you know, that's kind of the noise stop. And the aux stop means everyone hears it, but you know, everyone gets ready to hear it because they're not gonna hear it, but they never heard it. But the noise stop means they might have heard it, but you know, didn't get to hear it. And that's what it matters. It's anticipation. But you know, some people, you know, waiting for using the aux start or noise start because the noise start is often like the open motor, the start that kick the legs to start because it's a sprint, it's a race, it's 100 meters race, and the example is gonna give you on your marks, get set, to go. It's not a joke. So basically. So basically, the origami model for the calculus is basically based on the situation. So you get like a boat. You can take a piece of paper and make it into a boat, like a canoe or a boat, in literally, because you can fold paper or gramming, and you can fold it into some kind of a duck, flowing duck, a duck and a bird or crane, which is a bird flying, but they can do some kind of a star, which is like a star. It's a star like a samurai star. Which can chuck, can chuck because it's a ninja star. It's called a ninja star, and that's what I'm saying. It matters because it gives you area. So this is just introduced to the problem. I'm gonna get to the problem now, but I'm gonna do it properly. So this is a dendrite proof system, and what that means is it has to first got a formal procedure because it's calculus, you know what I'm saying, and welcome, OB Nexus Digital Tracing System, GitHub.com /O for Oscar, B for Delta, T for Tango, etc. This is the best. So basically, this is the derivation of the equation. This is 3t cubed plus 2t squared plus 7t plus 5. Standard first derivative. This first is first order derivative. But this is like the example one I used. But the problem is not around this problem. It's about the use of topographic error to calculate things with certainty that are biologically bound to the system. So I'm gonna give you the system without the biological state with it. But with the biological state, because it's not humanity. So if you can break something, if you build something, you can break it, and only you should be to break it because it's your program, and then you have to make sure you don't break it. You know what I'm saying? It's like, if I create a program. Yeah. Yeah, if I don't create a program, that means I cannot destroy it because I don't have the reference to that program. So if I create a chair or something, digital or physically, I create a chair, just my chair to sit on and you to sit down, but I can destroy it, and that's what this matters so much. Basically, it's what doctors use to prove stuff, in the competition, like for nursing, medicine, cutting patients down for surgery with the AI system. So this is my model of it. If I can create something, I can destroy it. If I can build something, I can break it. If I can renew something, I can repair it. Basically, if I can assemble anything, I can disassemble it. But I can assemble it in a way that no one else can redo it. Basically, it's bound to radiography. It's a protocol. Basically, it's the same radio channel, but it's quantum safe because I am more about quantum people hijacking my kind of a protocol. So in the quantum protocol, we have this kind of model. So what I'm going with here, this is a ghost actor. So basically, you get a ghost channel in the framework of the business to the problem. So you get voice modulation. Voice modulation is just like changing your voice on the radio, because this is just part of the framework. So that will give you can have like can pretend you're someone else, but someone else with a voice, which is an alias. So basically, if you're on a channel, channel 0, no, it's a channel fucking 0, channel 1, basically CH2, that's channel 2. If channel 2, that means you're channel 2 to 6. And then channel 0 is like the God itself, God, the person who owns the channel. Channel 1, channel 2 is the person who owns the channel. If you're channel 2 to 6, that means you're on 2, 3, 4, 5, 4 people on channel 2 to 6. And this is just like people that are there. So these people have other voices to be used because if the final change is hard, then when the persona changes, like when the interpretation of the message changes, they have different behavior. It doesn't matter the behavior what they're doing. They're gonna need to sound different, and pretend they're acting different to get basically change the way they communicate, but still in the same channel. Just make sure things don't get worse, and that's the policy on the. So it's like an open motor response to an increase of verification. So I've done all of that. Now, what's the proof about? So let's start. The proof is about dendrite. So a dendrite is basically a thing that has some kind of a processing request. Because I can think, basically, my thinking, when I think, I process information, I know I'm thinking. But when I don't know I'm thinking, I'm actively thinking, I'm thinking, but I'm acting on it. But I'm processing information, so I'm just doing that task. This is how much I have to, but it's like, and then I stop thinking because already I don't think about it anymore, and that's why I call processing because I process information, but I don't have to think about what I'm doing, in a sense as well. Because I don't think I'm thinking. So basically, example definition of process processing. So processing to not actively aware of what you're doing, but to do it with full consciousness, with full awareness, without thinking about the awareness you're in, because that means you're not actively calling yourself on the way, and that's why it matters. So the dangerous proof system for Pong is. So, the dendrite proof system for Pong is the gaps of basically it's like synapse gap. So basically it's like a neutron. The neutron has a synapse gap, and so. So it's like, some parts of neutrons through some information field until basically your bone has a bone marrow, but the dendrites have gaps. So basically, this is neurons are fire. And when they fire instruction, they have to go through the new gap, the synapse gap, to actually move you. And that's what I'm saying. They happen instantaneously. Based on how fast light can travel. Basically, if you can measure it, it's basically instantaneous. It doesn't matter. That's the goal. That's a wondrous goal. Because whatever you think most people should do, it's like the movement is very precise. If by how much you start instruction, how much you think, and how much your news can code what to do. So basically, the problem is Einstein's brain. Basically, Einstein's brain, they took it in a lab, put in cartridges, put in a computer. Einstein was playing Pong. So then why ask him why is Einstein going to do that? So why is Einstein learn to play Pong when I've been told? Because Einstein never played Pong. He never had the Pong, the Pong game in his time. He never. That was a long time later, and that's what his problem. I think you don't understand that. You don't understand the problem at all. But Einstein's brain, the neurons, just start playing Pong. No don't understand. Just as in the game of Pong, and not when you the game of Pong. That's what that means. It's still a problem, and he's not conscious. He just knows. That's just a dendrite. That's kind of a neutron. But the dendrite understands this interface is only a game interface for Pong. So that's the problem we're trying to address. How does a neuron know how to do something that's not been taught to do? Because there's no conscious, just electrical impulses that was about in the computer when it's on. When it's on, it comes to if it's going to the circuit board, it's not connected to anything. It's a brilliant computer, it's just going to circle the TPU. So So, 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 octostar. So you get green, blue, red. So it's like so dendrite proof for Pong gamer, Einstein neutron standard. Off star, no star. So basically you get -1 red, green, blue, but they represent the kind of the topographic state of readiness. Called them readiness. I think it was I think it was red. So red, if you're moving away red. If you're moving -1 red, that means you don't. That means you own that space. You hold that space. That red is entire space that you operate on, but you're not thinking about. You're not processing it. But it's information is getting from the Pong system. It's up and down, but it's not one way. So there's not going to be formal proof today because it's quite a long proof. But the goal is to use the AuDHD model I have. So double the space for half the time. Type 1. So type 1 is. I have double the memory or double the bytes. So you have 1,000 bytes, 1,000 kilobytes, 1,000 kilobytes. I have half the time. So half the time for 1,000 is 500. 500. So a kilobyte is 1,000. So you have 500 megabytes. Oh, thank you. 500 megabytes of time to run an algorithm, and this is like the space to time mapping. So this is space and time. So this is a space and time. So 1 kilobyte of space, thank you, to 500 megabytes of space is log n. So this is O of n. O of n. O of log n. Of log n, and that is log n. So it's like it's basically dimensional Pong because it doesn't matter dimension. The game Pong exists in the kind of coding of system. So we have to treat this problem because if you don't understand the problem, we don't understand how we are as human beings, how we are as biological entities, because we are the same thing. It's like what I expect from the system. If I have a tail, if a dog has a tail. Or reptile has a tail, I expect my tail to find its purpose, and that purpose is to like get the enemy, destroy the enemy while I run away, because that tail is not useful if I can regrow my tail like a reptile or a dog, because that's used for balancing. But if it leaves that balance, the enemy, the kind of predator should have taken that tail as something to eat because it needs to eat, and that's my expect from this model. But in the worst case, in the best case, forget right. But I don't have a tail. I have a fucking ass. My ass. If I fall down, I lose my ass, and I can lose my spine. Because it's like a chicken chunk, big chunk out of me because there's no range. And that's what I say. So it's basically an instruction set, like how does this work? So basically, it has to be an implicit instruction. So basically, I have to take a double time and half the space. But I'm probably type 1 autism. I have type autism, and then that means I have time second. So I have time second. Space first. I press the space. The more time to process. The space to process, and that'll be the space to break. Like whether it's like an area, a room, physical room, or mental room. I need no cloudiness. I just need. To see whatever information clear as possible. But if it's time I need more time. If I'm type 1, I'm polar, type 1 polar opposite. That means I'm time first, and that time first is double time. That'll be 1,000 KB in time, in seconds. seconds to 500 kb, 1000 kb is 500 MB in space to process. Because if I process, these are two axes. I have to maintain coherence. Basically, how do I? Basically, my fucking coherence operator. I forgot to use my coherence. Basically, the 95.4 coherence operator is basically gated. So the coherence operator is basically, and I am actually probably have to define my coherence operator proof, because the defined coherence has a correlation between two systems. But if the system isn't coherent, it isn't working together adequately, and that's what I'm trying to find out. So basically, coherence operator model the kind of dependency relation in real time and how they work together, but they have a correlation, and that's what coherence happens. So basically, they are potential differential equations that you solve simultaneously. You can use ODTS distribution to do this. So this is the ODTS distribution repository. So basically, this is a mathematical step by step. So this is something I give. Would like to give them. So you see, the first derivative is 90 squared plus 40 plus y 7, and this is just the first one. The second should be, this is the first derivative of space. So this space will be derivative first differentiation of a unit in the system. But one unit is not a shared unit. So this is one reference. This is not a unit. This is just a change in one system, one dimension, but it's not a unit that is shared in space and time, because the derivatives of the derivative is velocity. Now velocity means movement. So the actual derivative is 3t cubed plus 2 3 squared plus 7t plus 5. And this derivative for homogeneous change in velocity. But this change is not the area of no change at the constant rate. So basically, this is the integration, but this integration is not a shared space. And that's why this framework matters. So the second derivative is the one I want to talk about too, because this is iteration. So they can share the iteration and derivative. But the second derivative is what they can share, but the minor share. So this is the second derivative of 3t cubed plus 2t squared plus 7t plus 5 is 18t plus 3, and this is just the chair, because it keeps tracking the change of making you proof calculus. So you work with space time, but this is basically the proof of calculation. So I'm not gonna go through this properly, but I've just done that already. So the idea of this system is to use it for open model, to ensure people have motor neuron control as good as me, or better than me, because some people to have it too. The most the brain computing interface, no matter how if I can have the money to build, I don't need the money anymore, because I'm going to Munich after this, but so these are implicit instruction set. So the So basically, AG type 2 is polar's time first. So they have the problem with time, because time first means time to move, what I'm saying, and time to act, and time to do something. So this is no instruction, no star, implicit instruction. So basically, is there any? So after you get some, so basically, Einstein is playing Pong. It's like the brain is the implicit instruction. What implicit for me? It's not explicit instructions. It's what implicit instructions are set for Einstein's brain to know this world is a Pong world. You play Pong to get better. And that's what his brain is doing, because he was born and no taught him to make the theory of relativity. He just explored the world somewhere. He was just learning. He was ontological. And I'm going to say that I'm proud about Einstein, because Einstein did not go to do colonialism to get money. He was not corrupt, since he was like, following his own true path of science. Whether was doing was wrong or not, was not ashamed of it. It was, and that's what Shell was going. Wasn't good because of the kind of Shell was good because he took his time to do science. And it didn't matter what happened in the world; it was true. So, is space and time. So, this is a district, what we call district. So, freedom of movement. So, basically, it doesn't matter what I say, that's what the dictionary means. So, it means degree to do something. Dictionary means degree. So, it's, you can think of it as freedom, but it's not really gonna give you the word freedom. So, you're gonna have degree. So, the degree is basically bound by polar rules. And the polar rules are just like calculus with polar angles, and that's what matter. And that's what lapis comes in. So I'm gonna give you the framework properly. So you get polar, like a polar coordinate system. Twice space, path time, the structure, active. So you get active model and sparse model. So basically, you get the space, things you can model separately. You can trial and error, and trial and improvement. And that is the difference. Trial and error, trial and improvement. But you're actively doing that without knowing it. It's like, someone says no, you keep doing it, the same thing, until you get it right. Because it doesn't matter how much space and time they have for you, they've said no to you, but you know your hunch is almost there. This hunch is correct because they mean something out, and you keep exploring that avenue until you get that system correct. Because you can break it, you can build it, if you can create, you can destroy, you can renew, you can repair it. But the more failures you have, the more attempts you can get right. Doesn't matter how long you are, how much proof you have. All this quantum physics or not. You have this one task for life, to solve quantum physics. You have a quantum computer. That can solve the problem if the money is involved. And that's why the quality have no money, whatever is involved. Then you can do it. So that is open source. Open source quantum computers like Neutron or if I made Neutron, a quantum computer, I'm good at guys. So basically, it doesn't matter what the area, the shape of the problem is. What is the Coke snowflake? We give you area in real time. Basically, you can take the area of a Coke snowflake, which is 4/3 to the power 2 to the power of 3. Because you have 3 area, 3 axes for adding new areas become less. You can divide the triangles in 3, and you can repeat that indefinitely. Basically, the 4/3 is the ratio that the gives you the perimeter. The perimeter is the inverse area to the perimeter. So I think it's 4 divides. You get I do. 1, 2. Basically, the 4 axes. Basically, how many triangles? 1, 2, 3. Basically, they're 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. No, basically it's this axis. No, I think I'm wrong. Basically, I'm gonna try to use what I know. Basically, the axis of symmetry. So basically, if you divide the triangle, 1, 2, they get 3 axes of symmetry, which are 3 root 1, 1, 2, 3. So basically, you have a triangle, and you divide it into you have 1, 2, 3, 4, 5, 6 segment, 6 soft triangles. So you get 6/3. No, 6/3 is lines of symmetry, and the lines of symmetry. The definition that you can take. Basically some ratio you can calculate based on geometric construct. basically, how many auxiliary constructions can you make again? I believe this is what I call the C. Yeah, the 90 degree. You can get a C, two C's. So you get three triangles. So this you get three triangles. But because you get triangles, you can use the FZC, which is like standard trigonometry, like 180 angles, 180 degrees in a C, 45 degrees in basically, if it's a C, right angle, 100 degrees. If you get Z, you get 180 degrees, and you get F of 90 degrees. So, so basically, the login, the derive insertion of the system is based on lapis rules. So we get a dx over dy, which is standard integration procedure. The example, what the fucking thing I have. So if we have, let's go wrong. So if we have a colorway, which is like a basically, I can't remember what the term colorway means, but basically, what's a mathematical colorway? Fucking hell, mathematical colorway. Mathematical colorway. But this is bound by geometry. So in mathematical colorway is a theorem to connect by a short proof to an existing theorem. So this we gotta use because the colorway is geometric and it's basically you prove it with algebra. But if you can see that if you see the geometry, it's just a short proof, and that's why it matters. So it works. This is a geometric colorway integration, and this is the same. This is here. I'm showing you because I did prove colorway by induction. Because you can deduce it, you just have to deduce it, because it works as a colorway, and that's the beauty of the framework. It works with geometry, and that's why it's basically this is like a video I'm gonna watch now. Fucking hell.
In this video, I'm going to explain the differences between a theorem, corollary, conjecture, lemma, axiom, and proposition. Let's start at the most basic level, which is the proposition. So a proposition is just a statement that is either true or false. So for example, 7 is a prime number. It's a statement which is true, so it is a proposition. About 3 is larger than 4. Well, this is also a statement, but it's false, so it is a proposition. And a proposition can also be something like Washington, D.C. is the capital city of the U.S. It is a true statement and therefore is a proposition. So the following are not propositions. The first one is, what time is it? So this is a question and not a statement.
So basically, so this question is say true or false, but it's ambiguous. So it's very ambiguous. It doesn't fit the category of proposition. So I really extended it myself. Basically, this proposition can be true if you ask the right question, and that's what I'm saying. This matters. That's what I put in this video, because if I forgot that, a proposition is true. If I ask what time is it, not proposition. No. Is the time. Basically, if the question gives you the answer you want and it's correct, it's correct. It's a proposition. It's a self-indicting proposition that the neural system can verify via the Synapse program, because you already know what to do when you reach this tomographic sparse state, and you are actively processing that state without knowing it. You say.
Second one is, read this carefully. This is an instruction and not a statement. And the last one is x plus 1 is equal to 2.
So basically, this is a statement. Read this carefully. Carefully read this. It's like this is instruction. See what I'm saying? So basically, you see what game when this video is one I wanted to give you, because I watched this video before. Oh, 30 minutes. Oh, the fucking 9 minutes. Oh, fucking time. So the read this carefully. It's a great example I'll give you. I love you guys to have this analogy because my mind is fragmented because of this. Because if my mind was fragmented, if I couldn't think straight, I wouldn't give you an example. Because the statement, the mathematical statement is so you see something is true or false, but a proposition is either true or false. And that's where the beginners make a mistake. The statements and provision, because the provision can be true, and the statement can say.
Although this is a statement, it is neither true or false unless we know what is the value of x. And the next one that we have is an axiom. And an axiom is really basic. It's just a statement that we assume to be true. And we don't need to prove it. We just say, oh, here is a statement and just assume that this is true. So for example, a line can extend to infinity is an axiom. A lemma is a small result that has to be proved, and it is used to prove a theorem. So there are three parts to this definition. The first one is that it is a small result. It's not a significant result. Number two is that it must be proved. And number three is that the lemma is used to prove a theorem. A theorem is a significant result that has been proven. And a famous theorem is the Pythagorean theorem. So let's say you have these lemmas, these statements that you proved, and then from these lemmas, you prove something bigger. And that bigger thing is called a theorem. A corollary is a theorem that follows from another theorem. So for example, you have theorem A, right? So from theorem A, you do a bit of math and you discover something significant. And that significant thing is also a theorem, but it's also called a corollary. And the last word that we have for today is a conjecture. So a conjecture is something that somebody guesses to be true, but they have not been able to prove that it is true or false. So that's basically it for today. If you have any questions,
I still have a lot of conjectures to do because my work is a fucking Oxford, because I won't call all my work done. But the conjecture is there for me, and my time to get my data from my students because they're wasting my fucking time, and they're pissed because they know they're wasting my fucking time with my work. I really with an F-rated question. If I'm gonna make them be angry, and it's not fair because I don't have to ask my also when I want to come back. This is the pull on my face because that's my right service. I'm angry about it. Yeah. Thank you. So this is the kind of koi that Pyong. This is a man. His name is like I want to be called Koi that Pyong. I want to be no, not you. But because we can change it. But literally, I'm saying. So the goal of this is to try to prove that the implicit social matters happens. But it doesn't matter what the kind of demographic consciousness you have, which is heptagonal, which is seven-sided. You can divide the seven sides into a gen-drive system, and that'd be like if the if the area is 7 or 8 hexagon. So what I mean by that is heptagon. So a heptagon has 7 sides. It's a 7-sided polygon. So that means the 980 degrees. You can divide it. You can use it to process formation based on whether the formation interacts. So basically, you got a surface area, and that surface area is hooked to wherever the system has to play Pong is, because the Einstein's brain started playing Pong, and science are trying to prove it like a meme. So basically, a regular heptagon has 7 sides, but these 7 sides is basically have the sum of 980 internal angle of 980 degrees. But you can calculate this mathematically, and you don't break or pop. They don't. You can't break this because it's just a process formation in your head. That's why brain and but they put in the computer, and they start playing Pong. But this is the one that people have. 7. That's just I have 8 because this is conscious mode. So the edges represent a point of conflict or interest of who struggle. That that's a breakdown. When they work or not. But they can do it. If they just do it in time, in their own space and time, like homework, which is what homework is meant to be. But that's what I'm saying. So you get if you divide, for example, if you have an area of 1 plus 7, 1 plus 7.5, that's the area of it. You get 1. If you get 1 point, if you have the 1.1 and a 1/8, one octagon one, which is one I'm making so because I'm octagon. Let me use my same example. So you get 1 divided by 8 plus 1 divided by 8, but this is the area of the hemisphere. The area of the system, area of the octagon. I can define it in A because I guess the area shape of the sub-hexagons. Sub-hexagon, but basically the sub-octagon is the area is 1.5 because it's 1.5 every time. The area is 1.5, but that area starts from 1/8. Basically, 1/8 plus 1/8 plus 1/8. You get 1/8 plus 1/16. Plus 132, but the area of that dimension, of that sub is 1/7, and that so 1/8 to the power of 1/8 to the power of 1/8 minus 1, so 1/8 is 1/7, and that's because I'm eating 1/7. That's the error is 1/7 at the time because you maintain that one without thinking of that 1/7 dimension, and that's what people have that are made that are smart in the dendron system because the dendron system is not meant to limit you. It's like to make sure that your consciousness, your awareness of the problem is evolving with you. And the real world, that's the goal. The real world consciousness is evolving because there's no way to pop it because there's no more corners to fix you build. Because you already show that you know this stuff and you don't have to think about it, and that's what the framework gives you. You don't have to decide about it. So you get lapis calculus, which I was said here. Oh my days, this is 40 minutes. Fucking long now. Now you get lapis calculus. So lapis calculus. So you get lambda calculus. So lambda calculus is basically the power of calculus. So power of calculus just means you get differential, you get integration, but you get potential differentiation equation, and you get which is what the fucking guy used. But what is her name? The fucking guy used the science guy. But I can't remember that guy's name. But that guy was beautiful. And he let me. He just but whoever the quantum physicist's name was, the guy that was faithful for like I love that guy. He was the one that teach me why. But I love that guy. The kind of guy that's smiling. Teaching people. But when another teacher, I loved him. He was a quantum physicist, but he was the guy that famous at that time. I don't hate him, but we need new stuff. The teacher they never had, the quantum teacher, the teacher that they never had. That's what the people call them, in the schools. Yeah. So basically, you get the two the power calculus. So you get lambda calculus, and lambda calculus is a mathematical function. So this get the power for the ox star, which is start, and the power for the ox star, which means am I going to start on the noise star? Don't to start in case of an emergency. If you think about it that way, which is the noise star. So the ox star, particularly when I'm going to start, the noise star I'm going to start now because I don't know when I'll be in crisis tomorrow. Because the computer just start. It's just start a computer. So you get a NoSignal star, NoSignal oyster, signal ox star, which means you get information that you can process. You get no signal, you get no noise ox star, and then you get a noise ox star. And these are the 4 kind of star sequences for my system. And you get a power star, and the power star is like a lambda star, but this is just a symbol. You get a fucking symbol here. This fucking symbol here is the ox star, but that's like left bracket. So you get my calculus model do this, and my calculus model is 2 left lapis. So 2 left lapis, which is like 2 left integration. So 2 left, so that would be so because that would be 2 computer actor actress. But two left wrappers will be one right. So you get two left integration, which will be two right, two left things will be one right integration, which is one right lapis, because that's the rule for because microcontroller model. If you're feeling the breaking rule, for example, if you basically it's like it's just a Greek symbol, but if you get two lambda power, that's one lambda right lambda power, and the same thing applies to two left the power for the opposite lambda calculus model, because the double the power means you are turning the computer on, but you're gonna preserve the energy to turn it on, in the CMOS battery, and if that doesn't turn on, you really fucked up the first part of it, and you can use the power to turn on the system, and you can use but then if the power is what electrical, is not digital, it's electrical. That means the computer code is digital. So you have to save the power for all the time you see most you couldn't crash to turn on, and that's what the two right lapis. So you get one left lapis, which is one integration for half the start, half the start, which is half the start for the space and the power and the time the computer boots up. You have to boot up two cores. If one computer faces a beautiful order, and that's the lapis. So how does this work? So you get the power, which is modeled over the air system. Oh, you get stop the system of a calculus, but you get half of pi. So you get the pi framework here in all aspects of it. So you get from A to B. A to B. Yeah, A to B. A to B, so basically, A to B represent the axis 180 degrees polar rotation. So this is from point A of star to B, and this is how you model it. So it works on polar coordinate systems. They don't work on Cartesian. They do work on Cartesian very easily. That means they're working on static models. That's why it's done by coordinate systems. You can verify a star. Started. The calculator to verify star, and it's hard to verify star if you're using first order. Unless you're using basically if you're using Bernoulli's equation for this will be a Cartesian system. But basically you got any equation that lies in the symmetric equation plane of Bernoulli principle for quantum for calculus is the function, is the way it works, and that's the system of linear equations. Basically, they are system of linear equations that works on Bernoulli equations. But if because they're all Bernoulli equations solve first order problems, and that's the root of step one. Anything that's to be in a state of zero or no derivation would have to share the shared problem of Bernoulli equation. That's why it matters. So Bernoulli equations are what they are, but they're simultaneous Bernoulli equations because these two equations share a identity, which is one equation, but that equation has no change, and that's what that means. So, example, doesn't matter. So this simultaneous equation, 2x plus y equals 5 minus x plus y equals 2. Has a solution, and this solution is x equals 1 and y equals 5, and this solution is what they share in Bernoulli in a change or constant change of 1 and 5. You know what I'm saying. Many variables of them, but this is what I'm saying. So they should have formation for the power of lapis framework equation. Because lapis is the model of power and heat. They have power and heat involved in that. Animation. basically you can solve by substitution or elimination, and that's the beauty. It doesn't matter how you start the problem, how the problem was defined in your framework. It's just referential to you, because the problem is the structure wasn't determined for you to start. You just need to start the problem based on what the problem was from your angle. Say, what you probably should had, without thinking about it, without the time framework if necessary, because the time frame could have been the problem. You identified that it didn't work, and you just popped it, and that was your own, immediate own. Saying, it's okay.